For these systems, we are still going to be solving by substitution, and the difference is that in these systems, you'll notice that there isn't a variable that's by itself on one side of the equal sign, right? So here, x is being multiplied by -7, y is being multiplied by -2. Here, right, like the x's and the y's, there's nothing that looks like this, y equals or x equals. So in order for us to use substitution, this is the situation we need. We need either x to be by itself or y to be by itself. So in order to use substitution on either of these systems, we actually need to rearrange one of the equations so that x or y is by itself. Now, you can always rearrange an equation for x or y to be by itself. So like, for example, if I'm looking at this top equation, I could add 7x to both sides and divide by -2, and y would be by itself. I would end up with fractions over here. So what I try to do is when I'm looking at my two equations and I want to use substitution, I try to find, okay, what's a variable that's kind of easy to get by itself? And I notice, like, okay, for example, here, this x is almost by itself already, right? Like if I wanted to get this x by itself, right, because our first step here is we need to get a variable by itself. And what that's going to look like is for me to find a variable that's pretty close to being by itself. Over here, it's this x. And to just rearrange in a way that that variable is by itself on one side of the equal sign. So in this case, what I notice is that the only thing that's with the x is this -2y. So if I just add 2y to both sides, right, then I'll have, these are not like terms. This is 2y plus 11. Now this x is by itself, and now I can go ahead and after I get that variable by itself, I can just use substitution like before. And those notes are on page 8 if you need a little refresher, right? But I can just take this, right? This is x, and x is equal to 2y plus 11. So in this other equation, I can substitute in 2y plus 11 instead of x. So that looks like this. Right, that's -7x. I'm substituting this for x, and then I'm just going to write the rest of the equation. And I'm going to do the math here. So I get -14y, -7 times 11 is -77. This becomes -14y and -2y. Those are my like terms. Okay, so I have some big numbers here, but that's okay. If you need to use a calculator, you will. I'm going to add 77 to both sides. I'm looking to get y by itself. And I get, this is basically 77 minus 13. That's 64. And when I divide by -16 on both sides in order to get y by itself, I get y equals -4. So as always with systems, right, that is only half my answer. I know that y is 4, but I need to plug back in and find x. You can plug this -4 in for y in this equation, but the easiest is this equation because the x is already by itself. So if you just watch, right, I'm just going to do this since my goal is to find x. Oh, and whew, made a mistake here, right? This was supposed to be a -4. Okay, y equals -4. Let's make sure I plug in that -4. Okay, so here, right, this is just easier because this is just, right, I'm just doing 2 quick steps of math here. So this is my x equals 3. So my solution is 3, -4. Okay, so notice first I got a variable by itself, and then I just use substitution like I did before on page 8. And so this is really the new step. Okay, over here, let's do one more example. Remember, I'm looking for the variable that's easiest to get by itself. Now remember, I can always get any variable by itself. Like for example here, if I want x by itself, I could subtract y from both sides and divide by -5. Here, if I wanted x by itself, I could subtract 6y from both sides, I could divide by -3. That is all fine, but it's nice to just find, like, you know, the easier way. So what I notice here is that this y is already, like, you know, there's nothing being multiplied by it, so it's pretty close to being by itself already. So let's work on getting that y by itself, because all I have to do is just this one step where I add 5x to both sides. So I'm just looking for that kind of easier route rather than having to do 2 steps where I'm dividing and potentially ending up with a fraction. Okay, so here's my y is by itself, right? On one side of the equal sign, it's equal to 5x minus 2. So now I can go ahead and I'm going to plug it into here. So instead of y, right, I'm getting to this y right here. Instead of that y, I'm plugging in 5x minus 2. Now I'm going to speed up a little bit through this. Okay, I'm going to combine my like terms, and I'm going to cheat. I'm going to add 12 to both sides all at the same time. What I end up with is negative 12 plus 12 is 0, and then this is 27x. When I divide by 27 on both sides, you might know what's going to happen, right? My x is 0. Let's plug 0 back in right here. Five times 0 is 0, and 0 minus 2 is negative 2. So my answer is 0, negative 2. Okay? You're going to go ahead and try these problems really quick and check them, and then you'll be ready to try this activity in IXL to earn some extra credit.